Number 10, use the regular cone for parts A and B. Leave in terms of pi. So that's important information. To find the surface area, we first want to find the lateral area. So the lateral area formula is pi r L, where L is your slant height. Now, in this particular cone, I don't have the slant height. So to get the L, I'm going to do 8 squared plus 15 squared equals L squared. So that would be 64, and then 225. If I add these together, we get 289. To get L by itself, I square root both sides, and L is 17. I also know that 8 is my radius, and then 15 is the height of my square pyramid. So I would do pi times 8 times 17. First, I would multiply the 8 and 17, and that's 136. When you write it in terms of pi, you put the pi after the number. So this would be 136 pi. Oops, no. 136 pi for your lateral area. Now, your surface area is pi r squared. That would be the area of your base, which is a circle, plus your lateral area. And we already know that that is 136 pi. We know that the radius is 8, so we would do pi 8 squared. 8 squared is 64. 64 pi plus 136 pi. We would combine like terms, and we would have 200 pi. So that would be my surface area, and that would be inches squared. For part B, you have to find the volume. So I would do 1/3 pi r squared times h, that would be your height of the cone. So 1/3 pi, r again is 8, and the height is 15. So that would be 64. So I would do 64 times 15. That would be 1/3 times 960 pi. If I divide that by 3, because taking 1/3 of 960 is dividing by 3, you get 320 pi. So 320 pi inches cubed is the volume. Okay, for number 11, it says use the sphere for parts A and B. Using 3.14 for pi, round your number to the nearest whole number. So for the surface area, this is just 4 pi r squared. So our radius is 8. So 4 pi 8 squared. This gives me 4 pi 64. And if I take 64 times 4, we get 256 pi. It does say to use 3.14 for pi, and then round to the nearest whole number. So I get 803.84. The 8 makes the 3 go up to 804 meters squared. The volume of a sphere is 4/3 pi r to the 3rd power. So we have 4/3 pi. R is 8 to the 3rd power. And this is 512. So I have 4/3. 8 to the 3rd is 512. pi. So I take the 512 and I divide by 3. Let's just redo that. Let's do 512 times 4 divided by 3. And we get 682.6 repeating pi. But we're just going to multiply that by 3.14. And we get 2,143.57. We just take that 5 and make the 3 4. So this would be 2,144 meters cubed. For number 12, are the two figures similar? If so, give the scale factor. So in number 12, let's look at our radius compared. So that would be 4 over 8, which reduces to 1/2. And then our heights would be 9 over 18. And again, that is also 1/2. So they are similar. That's yes. And the scale factor is 1 over 2, or you could put 1:2. For 13, we're going to compare our height, length, and width. So 6 over 10, 3 over 5, and 2 over 4. So this one's pretty easy to do in our head. 2/4 is just 1/2. And we know that that does not equal 3/5 immediately. So are they similar? No. Is there a scale factor? No. So it's not applicable since we don't have similar figures. Okay. And then lastly, number 14, the surface areas of two similar figures are given. The volume of the larger figure is also given. Find the volume of the smaller figure. And so first, I need to figure out the scale factor of the two solids. So what I would do is I would take 16 over 100, and since that was area, then you would square root both sides. And that would give me 4/10. I would reduce that and get 2/5. Alright, so now that you have the scale factor, we do 2/5 equals the volume ratio. So we want the small figure on top, which we do not know the volume of. So that's going to be our x. The larger figure, the volume is given at 500. If I'm going from the scale factor to volume, I need to do a cube on the 2 and the 5, or to the third power. So this would give me 8, and then 5 to the third power is 125. Now I can go ahead and do cross products, so 125x equals 8 times 500, which would be 4,000. And if I divide 4,000 by 125, I get 32. So that's saying that the volume of the small figure is 32 centimeters cubed.